Now it is 8.
Bismillahirrahmanirrahim. Let's start with the quote of the day. Strongest among you is the one who controls his anger. Assalamu alaikum. I am Dr. Amna Khan. I'll be presenting a topic, skewness and poisson distribution, under kind supervision of my most honorable and humble and kind professor, Dr. Saira Afzal. Symmetrical distribution, a frequency distribution, is said to be symmetrical if the frequencies are equally distributed on both the sides of central value. A symmetrical distribution may be either bell-shaped or U-shaped. Bell-shaped or unimodal symmetrical distribution. A symmetrical distribution is bell-shaped if the frequencies are first steadily rise and then steadily fall. There is only one mode, and the values of mean, mode, and mode are equal. Mean is equal to median and is equal to mode. Standard normal distribution. You can see this from the normal, the graphical representation can show. What is skewness? Skewness is the measure of asymmetry of probability distribution of real valued random variable about its mean. Mean and median fall at different points in distribution. Its value can be 0, positive, and negative, or unidentified. Skewness was discovered by Carl Pearson in 1894. Asymmetrical distribution are seen when data is not normally distributed and does not show any asymmetry in mean, median, and mode. Where one tail is long but other is fat, skewness does not obey the simple rule. Within each group, the value on the right side of the distribution tapers differently from the values on the left side. These sides are called tails. They provide a visual mean to determine which of the two kinds of skewness a distribution has. Here in this graph, you can see the symmetrical distribution, mean and median, they coincide and their value is 0. So they coincide in the center. And this is the asymmetrical distribution. You can see the mean, median, mode, they do not coincide at the same point. There are following two types of skewness: positive skewness and negative skewness. Positive skewness, the mass of distribution is concentrated on the left of the figure. In the negative skewness, the mass of distribution is concentrated on the right of the figure. Long tail is the positive direction on the number line. Long tail is in the negative direction on the number line. The mean is also on the right of the peak. The mean is also on the left of the peak. This distribution will be said to be right skewed or positively skewed distribution. The distribution is called left skewed or negatively skewed distribution. Definition of measurement of skewness. The concept of skewness helps us to understand the relationship between three measures, means, median, and mode, as illustrated below. Here you can see the left negative skewed. Mode is more than median, and median is more than mode. Mode exceeds mean, and median distribution is skewed to the left negative. Mean exceeds mode, and median distribution is skewed to the right positive. Distribution is symmetrical when mean is equal to mode, median is equal to mode. Here is a graphical representation. So you can see it in the example. Skewness in data. In order to ascertain whether a distribution is skewed or not, the following test may be applied. Skewness is present if the values of mean, median, mode do not coincide. When the data are plotted on a graph, they do not give the normal bell-shaped form. That is, when cut along a vertical line through the center, the two halves are not equal. The sum of the positive deviations from the median is not equal to the sum of the negative deviations. Quartiles are not equidistant from the median. Frequencies are not equally distributed points of equal deviations from the mode. Rules of skewness. If the skewness is between minus 0.5 to positive 0.5, that is approximately symmetrical. If the skewness is between minus 1 to positive 1, it is moderately skewed. And if it is less than minus 1 or greater than positive 1, distribution will be highly skewed. Measures of skewness. There are three measures of skewness. The measures of skewness are Carl-Pearson's coefficient of skewness, Bowley's coefficient of skewness, and Kelly's coefficient of skewness. The Carl-Pearson's coefficient of skewness, here's the formula for the Carl-Pearson's coefficient of skewness, where this is the Carl-Pearson's coefficient of skewness and mean minus mode divided by the standard deviation. The coefficient of skewness will be, the formula will be, if mode is indeterminate, so the formula will be 3 into mean minus median divided by standard deviation. So normally the coefficient of skewness lies between +1. If the median is greater than mode, then the coefficient of skewness will be positive, otherwise negative. We can understand better with the help of an example. If the following values are given, mean is equal to 28, mode 23, and standard deviation 4.2, find the coefficient of skewness. So putting all the values in the formula, the answer will be 1.19, and distribution would be positively squared. Example number 2, if mean is 75.3, mode 84, and standard deviation 12.06, find the coefficient of skewness. So again, mean minus mode divided by standard deviation, put the values in it, we'll be having minus 0.72, distribution is negatively skewed. Example number 3, if the mean is this, median is this, and standard deviation is 5.83, find the coefficient of skewness. So putting all the values, we would get the answer 0. So distribution is symmetrical. Bowley's coefficient of skewness. Bowley developed a measure of skewness which is based on quartile values. This formula for measuring skewness is equal to, in this formula you can see Q3 minus Q2 minus Q2 minus Q1. These are the quartiles, and Q3 minus Q1. So this is the Bowley's coefficient of skewness. Q1 is first quartile, Q2 is the second quartile, and Q3 is the third quartile. This formula can be converted to Q3 plus Q1 minus 2 median, Q3 minus Q1. The value of coefficient of skewness is 0 if it is symmetrical distribution. If the value is higher than 0, it is positively skewed. And if the value is less than 0, it is negatively skewed distribution. Now, let's understand this with the help of an example. Here is Q1, Q2, and Q3. The values are given. Find the coefficient of skewness. So put the values in the formula. You will get the answer, that is 0.05. So the distribution is positively. Kelly's coefficient of skewness. Kelly developed another measure of skewness which is based on percentile and decibels. The formula for measuring skewness is P90 plus minus 2P50 plus P10 by P90 minus P10. So that is P90 is percentile 90, P50 is percentile 50, and P10 is percentile 10. Pertussis. It is another measure of the shape of frequency curve. It is a Greek word which measures bulginess. While skewness signifies the extent of asymmetry, pertussis measures the degree of pickedness of a frequency distribution. Carl Pearson classified curves into 3 types on the basis of the shape of their peaks. These are mesochaotic, leptochaotic, and platychaotic. In this graph, you can see all the 3 forms. This is the mesochaotic, and then leptochaotic, and the platychaotic. Poisson distribution is a discretely probability distribution that expresses the probability of a given number of events occurring in a fixed interval of time or space if these events occur within a non-constant mean rate and independently of the time since the last event. This is the graphical representation, and you can see the Poisson distribution being distributed on the graph. Need of Poisson distribution. It is used in cases where the chance of any individual event being a success is very small. The distribution is used to describe the behavior of rare diseases. For example, incidence of autoimmune alveolar proteinosis in Japan, incidence of male mortality due to brain cancer, incidence of lymphoangiomyomatosis in females. The Poisson distribution has following formula. So P for any random variable, which is x is equal to 1, 2, 3, 4, is equal to E. E is the base of natural logarithm, which is equal to 2.7183. E2 minus M times M to X by X factorial. M is the mean of Poisson distribution, that is the average number of occurrence of an event. The random variable X should be discrete. So the condition under which Poisson distribution is used would be the random variable X should be discrete. A dichotomy exists, that is happening of the event must be of 2 alternatives such as success and failure. Applicable in those cases where the number of trials is very large and the probability of success P is very small, but the mean NP is equal to M is finite. Statistical independence is assumed. Properties of Poisson distribution. Discrete probability distribution. The Poisson distribution is a discrete probability distribution in which the numbers of success are given in whole numbers as 0, 1, 2, and onwards. Value of P and Q. Poisson distribution is used in those situations where the probability of occurrence of an event is very small. P minus 0, and probability of non-occurrence of an event is very large, Q minus 1. Main parameter, it has only one parameter M, and the value is equal to NP. So M is equal to NP. Constant of Poisson distribution, the constant of Poisson distribution can be obtained by following formula. Mean, which is equal to M, is equal to N times P. Variance is equal to M. Standard deviation is equal to root of M, and moment coefficient of skewness is equal to 1 by root of M. Moment coefficient of kurtosis is equal to 3 plus 1 by M. Equality of mean and variance, it means its mean and variance are equal. Mean is equal to variance. The Poisson distribution is a discrete distribution with a single parameter, M, mean. As M increases, the distribution shifts to the right. All the Poisson distribution is skewed to the right. This is the reason why the Poisson probability distributions has been called the probability of distribution of rare events. Application of Poisson distributions, application of Poisson distribution formula, and then the fitting of Poisson distribution would be seen. So let's understand this better with the help of example. The average number of accidents at a specific place every year is 18. There are three possibilities. So first, calculate the possibility that there are exactly two accidents. Then calculate the possibility that there is at least one accident, and then calculate the possibility that there are more than two accidents in a particular month. Let's start with calculating the probability that there are exactly two accidents happening this month. So there are 12 months in a year, so lambda is equal to 18 by 12, which is equal to 1.5. 1.5 per month. So putting the values in the formula will get the answer 0.2510. Calculating the possibility that there is at least one. So we are calculating the possibility for a random factor which is more than or equal to 1. So taking the complement as x is equal to 0 and putting the values will get the answer 0.22313. So at the end, putting this in this formula, we'll get the value which is 1 minus 0.22. What is the probability that there are more than two accidents in a particular month? So now we'll be assuming that the probability for the random factor x would be more than 2. So the formula would be altered accordingly. There are infinite numbers of cases, so instead consider x is more than or equal to 2. So putting the values in the formula, we'll be getting the answer, which is 0.192 or 0.1912. So you'll calculate by actually understanding all the formulas, and then you understand this by putting the values. So when you will practice this, you'll understand this better. In conclusion, we can say that the Poisson distribution is useful in rare events where the probability of success P is very small and probability of failure Q is very large and value of N sample is very large. Let's start with recent updates now. Diffusion kurtosis imaging histogram parameter matrix predicting survival in integrated molecular subtypes of diffuse glioma, an observational cohort study. Abstract. So the purpose is, the aim of the study was to access predictive value of preoperatively assessed diffusion kurtosis imaging matrix as prognostic factors in the 2016 WHO, or the World Health Organization classification of tumors of central nervous system integrated glioma groups. Now it's time for MCQs. Let's start with MCQ number 1. Ali was presenting a data of research. He understood that there is asymmetry in the random variable and fat tail of curve is more towards the left. What type of skewness will be there? A, absolute, B, relative skewness, B, C, positive skewness, D, negative skewness, E, Kelly skewness. Anyone?
D.
No, that is C, positive skewness. You can always understand, you have to see the tail. So it's towards the left side. After doing a study about the death of laborers on the working side during analysis, he observed that mean is more than mode and it lies on the left side of the peak. The data was showing which type of skewness it would be. So the answer would be A, negative skewness, B, positive skewness, C, Pearson skewness, D, absolute skewness, E, Kelly skewness.
B, positive skewness.
Yes, exactly. B, positive skewness. Question number 3. After doing a research, Qasim calculated the skewness value of -5. So this data will be showing which level of skewness? Symmetrical, B, approximately symmetrical skewed, C, moderately skewed, D, approximately moderately skewed, E, highly skewed. It's E, highly skewed. Question number 4. After doing a research, Amna calculated that mean was 60, mode was 30 with standard deviation of 5. What would be the skewness considering that Karl's Pearson coefficient? Here's the calculation for that as well. So you have to understand that you need to understand the formula first. Put that all the values in the formula, the answer would be 6. Question number 5. After calculating the data, Ahmed observed that mean is equal to 4, standard deviation is equal to 12, and median is equal to 4. So what would be the distribution of this data according to the Karl Pearson's coefficient? A, symmetrical distribution, B, positively skewed distribution, C, negatively skewed distribution, D, Corteusis distribution, and E, Poisson distribution.
B.
A, symmetrical distribution.
E, Poisson distribution.
It would be A, symmetrical distribution. Question number 6. For the calculation of skewness, Jabir get the following data in quartiles. Q1 is equal to 30, Q2 is equal to 10, and Q3 is equal to 40. What will the skewness considering this data? So basically, you would again put the values in the formula. So by putting them, you can understand what is the answer, that is 5. So answer would be A. Question number 7. Zishan was asked by his friend to help him about the measurement of the skewness of data, which he collected on research of diabetes. When he saw the data was in percentile, which of the following will be used to measure the skewness? A, Karl Pearson's coefficient, B, Bowley's coefficient, C, Corteusis, D, Poisson distribution, E, Kelly's coefficient. It would be E, Kelly's coefficient. Question number 8. While presenting the data on a frequency curve, a lot of data was falling in the center of curve, making a peak more than normal bell-shaped curve. What name will be given to the curve? A, normal distribution curve, B, platycurtic curve, C, mesocurtic, D, leptocurtic, or E, positively skewed curve?
D.
Yes, it is D, leptocurtic. Question number 9. A doctor is thinking to conduct a study about the leptin deficiency syndrome in the subcontinent. Which distribution he should be used to present the data? A, normal distribution, B, skewed, C, Corteusis, D, Poisson distribution, E, none.
Alpha.
No, that would be Poisson distribution. Question number 10. Aslam was researching about incidence of Alice in the Wonderland syndrome. What distribution will be used to present the data of disease in Pakistan for 2 years? Normal distribution, positively skewed distribution, negatively skewed distribution, Poisson distribution, E, Corteusis. That is D, Poisson distribution. Here is the key of the MCQs and the references here. The link of the YouTube channel, everyone, please like and subscribe. Here's a lot of good knowledge being shared, and you can see the knowledge there being displayed always. Thank you so much, everyone, for listening.
Assalamu alaikum.